Welcome to Cosmoquark channel. So today's topic is what is units and what is physical quantity. Before going to study about units and physical quantity, so we have to understand what is measurement. Okay, so measurement is a process of determining the size, quantity or degree of something by comparing it to a standard unit. Okay, so now we have to understand what is unit. So unit is an arbitrary chosen standard that widely accepted and used to measure a physical quantity. It's a arbitrary chosen standard that widely accepted and used to measure physical quantity. So then what is physical quantity? Physical quantity means a quantity which can be measured and by which various physical happenings can be explained and expressed in the form of laws are called physical quantities. A quantity which can be measured and by which various physical happenings can be explained and expressed in the form of laws are called physical quantity. That's why physical quantity is very important. So to understand the laws of physics. So length, mass, time, force, all these are the example for the physical quantities. So now the next topic is why measurement is necessary. Okay, why we have to measure anything. So to determine the magnitude of physical quantity, so measurement is very important, and to compare any two similar physical quantity. For example, in the class, suppose if you want to compare the height of two persons, so then measurement is very important, and to prove physical laws is also measurement is very important. So that means if you want to prove F is equal to ma, so we have to find acceleration, so we can find force. So that's why measurement is necessary. So now we can't use everything as a unit. So for standard unit, so there must be some condition. So what is the condition? It should be invariant across time and space, and it should be easily accessible, and it should be easily reproducible, and it should be universally acceptable. So these are the conditions for a standardized unit. So next, for any physical quantities, there will be two components. So the first component is called numerical value. It indicates the magnitude of physical quantity. Okay, numerical value indicates the magnitude of physical quantity. And the next component is unit. So unit specifies the measurement standard. Okay, as I already said, unit already we discussed, right? So unit specifies the measurement standard. Okay, so now that's why physical quantity can be represented as a product of numerical value and unit. Okay, so any physical quantity so is represented as n into u. That means it's numerical value, n means numerical value, and u means unit. So just write a note. While expressing certain physical quantity, it is clear that as unit changes, the magnitude will also changes. That we already know, right? As unit changes, magnitude will also changes. So we can say 1 kg is equal to 1000 gram. See, so 1 and 1000. So similarly, gram and kg. As unit changes, so its magnitude as well as so unit both will change together. So that's why we can say n1 u1 is equal to n2 u2, because the product of magnitude and unit will always be constant. So that's why we can say n is inversely proportional to u. As n increases, u decreases. As I said, 1 kg is equal to 1000 gram. 1 is less than 1000 and gram is less than kg. So now classification of physical quantities. Okay, so how we can classify physical quantities? So there will be two things. Okay, here we have to discuss. So first, on the basis of directional property, that means using direction we can define or we can classify physical quantities. So physical quantity can be divided into two types. One is called scalar and another one is called vector. I hope you already know these things. So scalar is nothing but which has only magnitude but no direction. Okay, so scalar means it has only magnitude and there is no direction. Vector means which has magnitude as well as direction. And one more thing, so vector, it has to obey some rules as well. That's called vector algebra that we will going to discuss later. Okay, mass, time are the example for scalar and displacement, velocity are the example for vector. So we can give so many examples. So suppose if you want to see the next classification, so this is on the basis of dependency. Okay, physical quantity can be divided into three major types, that is called fundamental quantities. So these are also called as base quantities or absolute quantities. The next thing is derived quantities. Okay, so and the next specification is supplementary quantities. Okay, so these are the three types of physical quantity which is on the basis of dependency. So now, what is fundamental quantities? Fundamental quantities does not depend on other quantities for their complete definition. For example, there are 7 fundamental quantities actually. So length, mass, time. These are the quantities, they are independent of other physical quantities. So that's why it is called base quantities. And then what is derived quantities? The quantities which can be expressed in terms of base quantities. Okay, so we already defined base quantities. Suppose if you are defining any physical quantities in terms of base quantities, then it is called derived quantities. Okay, so velocity, acceleration are the example for derived quantities. The next thing is supplementary quantities. They are neither fundamental nor derived quantity. Okay, such things are called supplementary quantities. Plane angle and solid angle are the supplementary quantities. So these are the classification of the physical quantity. So now, as I discussed, there are 7 fundamental quantities. So they are mass, length, time, temperature, electric current, luminous intensity, amount of substance. There are 2 supplementary quantities. They are plane angle and solid angle. Okay, so as we already discussed, so there are 2 supplementary quantities. They are plane angle and solid angle. 2 supplementary quantities were created to measure purely geometric concept. So to explain that geometry we need supplementary quantities. They are neither fundamental and nor derived. Okay, so such type of quantities are called supplementary quantities. Now we are going to discuss what is plane angle. The angle between 2 intersecting lines or planes in 2D is called plane angle. It is defined as the ratio of length of arc to the radius of circle. The ratio of length of arc to the radius of circle. That is d theta is equal to ds by r. So where d theta is the angle subtended by the arc ds and r is the radius of the circle. So now what is solid angle? So this measures amount of space enclosed by a conical surface at a point. Okay, this measures amount of space enclosed by a conical surface at a point. So it is defined as ratio of intercepted area, that is we will say dA, of the spherical surface to the square of the radius. It is defined as ratio of intercepted area of the spherical surface to the square of the radius. So this is represented by omega. The symbol is called omega. D omega is equal to dA by r square. dA divided by r square. See, This is a conical portion, so this is called d omega and this is dA. The next discussion is about units. Units is an internationally accepted standard for measuring a physical quantity. Okay, it is an internationally accepted standard for measuring a physical quantity. So there are different system of units. Okay, so there are different system of units. For example, FES system. So this is the first system of units. So where length is measured in terms of foot, mass is measured in terms of pound, and time is in terms of second. And the next system is MKS system, where length is measured in terms of meter, mass is measured in terms of kilogram, and time is measured in terms of second. The next system is CGS system, where length is measured in terms of centimeter, and mass in terms of gram, and time in terms of second. The system of unit is SI unit. So this is internationally accepted system of units. Okay, everyone and every corner of the world will use that. So this is called SI unit. SI unit has 7 fundamental units and 2 supplementary units. So this is another version of MKS units. Okay, or MKS system. The next discussion is about classification of units. We already seen the classification of physical quantity. Similarly, so units are also classified. So the first classification is fundamental units. So fundamental units is nothing but the units of fundamental quantities. Okay, so there are 7 fundamental quantities. So that's why there are 7 fundamental units as well. So in that, first we are going to define meter. Meter is a fundamental unit of length. So for every fundamental units, there will be 2 definitions. One is old and another one is new. Old is before 2019 and new definitions are after 2019. And new definition always use a physical constant. Okay, so old definition of length is, it is based on the distance from Earth equator to North Pole. And new definition, length of the path travelled by light in vacuum during a time of 1 by 299792458 of a second. That means around 1 by 3 into 10 to the power 8 seconds. That is the speed of light. The next definition is of kg, that is kilogram. It's a fundamental unit of mass. So the old definition of kg is actually, it is the international prototype of the kilogram. That is, it is a platinum iridium alloy which is kept at International Bureau of Weights, which is located near Paris. Okay. The new definition of mass is defined using a Planck's constant. It's a constant that is equal to 6.62 into 10 to the power minus 34 joule second. So we already know E is equal to mc square and it is equal to h nu. For mu is equal to 1 hertz, m is equal to h nu by c square. So by knowing Planck's constant, we can define kilogram. So this is the logic. Okay. So the next definition is about a second. It's a fundamental unit of time. So before, the unit second is defined using earth rotation, but now, so it is defined using a cesium clock. So cesium 133 has a 55 electrons, where 55th electron is unstable. So this will do a transition from one orbit to another orbit. So that's why 1 second is the time taken for 9 billion vibration. So this is the definition of, that means new definition of second. The next thing is ampere, that is the fundamental unit of electric current. So the old definition of ampere is as follows: current through 2 parallel conducting bars of equal length spaced 1 meter apart with diameters is very much smaller, okay, than length, is called 1 ampere if force per unit length of the bar is 2 into 10 to the power minus 7 Newton per meter. Okay, so the force should be 2 into 10 to the power minus 7 Newton per meter between the bars. So this we are going to learn in detail in second PUC in the moving charges and magnetism chapter. Okay, now it is defined using a charge, that is an elementary particle, that Q is equal to 1.602 into 10 to the power minus 19 coulomb. So this is the constant used to define ampere. Now we have to define next fundamental unit, that is Kelvin. So it's a fundamental unit of temperature. Okay, so Kelvin is the fraction 1 divided by 273.16 of the thermodynamic temperature of the triple point of water. So what is triple point? Triple point is the point at which water, ice and water vapor coexist in equilibrium. So now it is defined using Boltzmann constant. It is a new definition. So Boltzmann constant is equal to 1.38 into 10 to the power minus 23 joule per Kelvin. The next definition is about mole. So this is a fundamental unit of amount of substance. Okay, so the old definition is amount of substance in 12 gram of carbon 12. Now it is defined using Avogadro number. Okay, 1 mole is nothing but 6.023 into 10 to the power 24 per mole. Okay, the next definition is about candela. Okay, it's a fundamental unit of luminous intensity. Okay, so the older definition of candela is a luminance of black body radiator at the temperature of freezing platinum. Okay, it's a luminance of black body radiator at the temperature of freezing platinum. Okay, so now the new definition is, it's nothing but it's the intensity of source that emits monochromatic radiation of frequency around 540 into 10 to the power 12 hertz, and that has a radiant in that direction of 1 by 683 watt per steradian. Okay, so it has a radiance in the direction of 1 by 683 watt per steradian. Okay, so these are the definition of fundamental units. So the next discussion is derived units. Derived units. The units of derived quantities, or the units that can be expressed in terms of the base units, are called derived units. Okay, so that means the unit of velocity. This is the example. Okay, the unit of velocity is usually we will represented in terms of meter per second, where meter and second is the fundamental quantity, right, or base units. So that's why these are the derived units. So for example, the unit of density, that is kg per meter cube. Here kg and meter is base units. Okay, unit of density, that is kg per meter cube, where kg and meter is base units. The next discussion is about supplementary units. The units of supplementary quantities are called supplementary units. The units of supplementary quantities, because we already defined what are the supplementary quantities, so its unit is called supplementary units. So first we are going to define unit of plane angle. Okay, because plane angle is the first supplementary quantity we define. So SI unit of plane angle is radian, and its symbol is rad. Okay, so we will write RAD, and we should not pronounce RAD or rad, so it should be pronounced as radian. And now what is the definition of 1 radian? Okay, 1 radian is defined as the angle subtended at the center of a circle by an arc equal in length to the radius of circle. 1 radian is defined as the angle subtended at the center of circle by an arc which is of length which is equal to radius of circle. Okay, Angle are often measured in terms of degrees, minutes and seconds. Okay, angles are often measured in terms of degrees, minutes and seconds. So we have to know about this fact, that is 1 degree should be equal to 60 minutes and 1 minute is equal to 60 seconds. 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. And for the conversion we have to use 360 degrees equal to 2 pi radian. This we already know in the chapters we already learned in 8th, 9th, 10th, so in the geometry. Okay, and as we know that 360 degrees equal to 2 pi, so that's why 1 degree is equal to 2 pi by 360. So 1 degree, so that's why approximately equal to 1.74 into 10 to the power minus 2 radian. And 1 degree we already know that it is equal to 60 minutes, so that's why 1 minute can be written as around 2.9 into 10 to the power minus 4 radian. And similarly 1 minute is equal to 60 seconds, so that's why 1 second is equal to 1 by 60 minutes, so that's why 1 second is approximately equal to 4.833 into 10 to the power minus 6 radian. So the next thing is unit of solid angle. Okay, SI unit of solid angle is steradian. Okay, steradian, and its symbol is SR. Okay, small letter SR. So now, what is the definition of steradian? Okay, one steradian is defined as the solid angle subtended at the center of the sphere by a surface area equal to the square of the radius of the sphere. Okay, one steradian is defined as the solid angle subtended at the center of the sphere by a surface area equal to the square of the radius of the sphere. A sphere with the radius of 1 meter, okay, a sphere with the radius of 1 meter has a surface area of 4 pi meter square. Okay, a sphere with the radius of 1 meter has a surface area of 4 pi r square, right? So it has a surface area of 4 pi r square. So that's why the total solid angle around its center is 4 pi steradian. Thanks for watching. If you found this video helpful, don't forget to like, subscribe and hit the bell button so that you never miss a new lesson. Keep learning, keep growing, and I will see you in the next video.